the real challenge of using a platform like this is trying to figure out how to adapt it to your system of choice. So if you learn like a model on, I don't know exactly what's being taught this year, but if you do like a COVID model or something like that, how then do you adapt that to some other like a viral system that you happen to study? Or if it's a model of lung infection, how do you then take that and look at a model of like liver infection or something? um those types of choices and how to make those choices, that's stuff that we can't really teach in lecture format, but getting experience with that during the hackathon is really what's essential to learning how to do this virtual tissue simulation. So with that said, I think we'll go ahead and start. And remember that the call is recorded and live streamed and distributed. So with that in mind, let's go ahead and proceed. So I want to talk about functions now. So far, what we've done is we've talked about the different types of objects in Python, different data types, and we've done some for loops and stuff like that. You could imagine trying to do a bunch of for loops all the way through, the thousands of types of things that we're simulating could get very cumbersome. One of the ways in which complexity of action is managed in Python and other programming languages is something called a function. So functions are little bits of reusable code that basically do the same thing each time. So the way to think about this is, the analogy I like to use is comparing a rice cooker with an open flame. So like an open flame in your kitchen or a stovetop in your kitchen, you can cook anything, right? You can completely modulate all the temperature and the duration and whatnot. And so you can, like, regardless of what you're making, whether you're making eggs or steak or whatever, you can come up with your protocol for doing that and do it each time. Whereas a rice cooker can pretty much only cook rice, or other grains of that sort. It's going to take a certain amount of input, the amount of weight of the rice that you put in there. It's going to sense that, and based off of that, it's going to produce a certain amount of heat for a certain amount of time, and it will cook rice perfectly each time you use it. So when you have a repeating task in Python, when you have something that you're doing over and over and over again, what we like to do is put that into a function so that we can use that set aside piece of code, that repeatable piece of code, and use it on different things. It's like a template. It's like a cookie cutter template. You can put whatever into it and you'll get that shaped object out of it. So let's talk about some of the vocabulary here. So functions are not run in a program, so that you define them in the program, but you don't actually use them until they're called or invoked. So if we talk about invoking a function or calling a function, that's what we're talking about. And then function has certain characteristics. They have the name of the function, the parameters, and sometimes there's zero parameters, but parameters is what the input to the function is. And then there's a docstring, which explains what the function does. And then there's a body, which does the things, the body is the kind of the equivalent of the expressions in the conditionals we did last time. And then finally, there's a return, whatever gets returned from that function that you can use later. So that's all kind of abstract. Let's look at that in context. So here's an example of a function. So remember earlier in our for loop, we were checking whether or not a given number was even based on whether it was divisible by 0. Well, you could put that into a function, so you're doing it over and over again. You have the keyword def, which is the sign of a function. It's saying define. We're defining the function called is_even, and it's going to take one input parameter or argument. So it means you're allowed to enter in one piece of data at a time. Here's a docstring that explains what happens. And what's happening in this function is you get input I, which has to be an integer, and a positive number for it to work properly. And then it returns true if I is even, otherwise it returns false. And then, so the doc string is set aside by 3 quotation marks above and below. So everything in there get interpreted by Python. It those by having a triple set of quotation marks before and after, it knows that that's just a comment for the reader. And then inside the body of the function, which is indented, we have what we want to do with our input. So first, regardless of what it is, we're going to print inside is even. And then we're going to print return the outcome of this conditional. So if the input modulo 2 has no remainder, it means it's even. If it's even, we return true. If it's not even, we return false. The way you call the function is anywhere else in your code after this has happened, you just call the name of the function and then you enter in what input arguments you need. In this case, you need one input argument. So your return is even 3. And in this case, you can tell it's going to print inside is even and it's going to print false because it's not an even number. So let's enter that in and see what that looks like in Jupyter Notebook. So if you've left like I have, if you left NanoHub, just go to nanohub.org. And there's Jupyter right there because I have it saved. If you don't have it saved, you can go to nanohub.org/tools/Jupyter. All right. And then you can launch the tool. All right. And you can see where we did module 1 and module 2. I'm going to go ahead and do new Python 3 to get a new notebook. Okay, I closed some of those, so hopefully it runs faster now. File, I'm going to rename it module 3. All right. And let's enter in the function that we have over there. So define is underscore even I. I include that column there, and it's going to indent for me automatically. My doc string input So there's my doc string. Notice it's in brown. It's not getting interpreted. And now I'm going to go ahead and run this with my shift enter. And it ran. So now I can do is even 3. False. Is even 66, true. So I can use this anywhere. So what this does is, instead of me having to do that conditional over and over again, I just always refer back to is even anywhere in the code. And it makes the code shorter and easier to read. There's a tool, there's a mnemonic in Python, DRY, don't repeat yourself. And that is better than WET. Dry is better than wet in Python. So WET is write every time, and we don't want to write every time. We want to use these functions and other tools like that. So again, highlight return is also a keyword. It's in green. All keywords are in this bold green. And then this is the expression that's going to get evaluated and returned. Okay. Now we need to talk about something called variable scope. This can be somewhat confusing until you get the hang of it. Notice I use this variable I here, right? I, and then it refers to I over there as well. Now, if I'd set Z equals 33, and I do is even Z, and I do, okay, I say I equals 4. If I do is even Z, oops, sorry, is even Z. Now, if I run this, are we going to get true or are we going to get false? Just make a mental prediction for yourself, and I'll run it. And we get false. Because even though this says I equals 4, this I variable is just a placeholder. It's just true inside. It's just referring to I inside this function. We call that a local scope or local environment. When we assign 33 as Z, and then we run this function on Z, Z is going to take the place of I inside of all of those actions of that function. So it doesn't matter what I is. The fact that this is I and this is I is entirely coincidental. What argument or variable gets entered into here into the parameter / argument space, that's what the function gets run on. So I don't know if I said that super clearly, but let's do some examples that will kind of make that clear. So we're going to define another function. Oops. It's going to be f of x. So the function is named f, and x is the input argument. X equals x plus 1, print in f of x x is equal to so if I do x is equal to 3, and then I do y equals f of x, and I run it, I've said x is equal to 4 inside this function. Outside of that function, in the global space, print x. X is still equal to 3. Even though x got updated inside the function, outside the function, it didn't get updated. And y is equal to 4, because y, what we returned, the variable that we returned, got assigned to y. So now y is equal to 5. Now, if I run this thing again, Let's say, yeah, y equals f of y. So y was 4. Inside the function, x is equal to 5. Outside the function, y is equal to 5. Outside the function, x is still equal to 3. Does that make sense? Anyone confused by that? Basically, what we're trying to say is that the variables inside the function, when you're inside the function, the variables inside the function take precedence. And then once you're outside the function, the information that's outside the function takes precedence. So this is that same example. In the global scope, you have global means accessible from everywhere. In the global scope, you have x is 3, and you have z as the output of this function, and then you have a function object called f, but you don't have access to the x that's inside there. Now, one place that gets particularly tricky is if you don't have a return statement. Functions are not required to have a return statement. So let's copy our is even function from before. We'll call it is even 2. It's best practice not to overwrite your stuff unnecessarily. Okay. So I haven't run it yet, right? That's empty, but I'm going to hit Shift Enter, and now I've run it. So what was Z again? Z was 33. Okay. So if I do is even to 33, sorry, Z, nothing got returned. So if I say y equals is even to Z, let's say y2. So let me do this, print y2. None, right? It doesn't have a value because there's nothing got returned. So that's one way that this structure can be tripped up, because it has the absence of a value. Okay. So this is a little bit tricky. You guys are probably all familiar with Fibonacci numbers. It's a function that a Fibonacci series is, and if you know how to read this, it starts at n, starts at 0, then it goes to 1, and then it goes to the previous step plus the previous step before that. So in this case, 0, 1, 1, and then after that, it goes to the previous step plus the previous step. So it goes to 2. And then after that, it goes to 2 plus the previous step is 3. So what we want to try to do now, and it's okay if you don't necessarily get this, using what we've learned today, try to write a function that will produce a given number of a Fibonacci series if based on the input. Like if you input 3, it wants the third number of the Fibonacci series. And the hint is that this is recursive, so the function has to call itself, basically. Okay. So it's 309. Let's spend the next 4 minutes trying this. Let's go to 313, and then if you don't get it, it's totally fine, but we just want to make sure you understand it once you see it. So one thing to think about based off of this is if n is 0 or 1, there's one way to define it. And if n is greater than 1, there's a second way to define it. Okay, I'm going to throw this poll up to see where we're at. Hayden, do you have this information?
Sorry, what information?
Do you have the poll information collected?
Yeah, yes, I did.
Okay.
Oh, okay, for the previous poll. Yeah, there we go.
Yeah. Okay. I'm going to go ahead and wait another minute till 3:15, and then we'll kind of talk it out together. For whoever needs help, if you want to send a message to Hayden or someone else in the chat, then they can either get you into a breakout room or answer your question through chat itself. Okay. So just to try to one way I start on these things, and again, this is a little bit orthogonal to actually using CompuCell, but this is something we teach in our coding classes, and I think it's an important concept to kind of be aware of. I will go ahead and lay out like what the expected outputs are. So what is the expected output of a Fibonacci series? It starts like this, right? And then the function that we want is going to read in based on some number, on some input number. It's going to give that term of Fibonacci. And we're going to go ahead and zero index just like Python does. So if you enter in an input of 0, we want 0. If you enter an input of 3, we want 2. If you enter an input of 6, we want 8. So how do we get it to do that? Well, the first thing we got to do is set up our function. So I use my def statement for define. And then we need an input argument, right? So let's call it n. Now, one thing to notice is for these first two, the Fibonacci, the number in the series is equivalent to the index of the series. So in that case, we use our conditional if n is less than or equal to 1, we can go ahead and return n. We can return n, right? If they enter 0, we can return 0. If they enter 1, we can return 1. Now we got to deal with the rest of this. So we go to else. So if we want to get this second number, how do we do it? Well, we go back to the formula here. A given number in a Fibonacci series is equal to the last two numbers in the series added together. So we're going to return the last two numbers in the series added together. Okay, so let's test this out. So this worked, right? Yeah, so it works. If you go that far in, it takes a little time to work, but it still works. So how did this happen? I trust that everyone understands this part, right? If it's the first two numbers in the series, the output is equal to the input. Okay, the output is equal to the input. If it's not one of those two numbers, then we just have to get the previous two items on the list added together. So this 8 is the sum of 5 and 3. This 13 is a sum of 8 and 5. So we call so if we have an input of 13, we return fib 12 plus fib 11. And so what is fib 12? Well, Python goes through it again. So it goes for 12. And it says, so actually let's write it out. Let's not do it with 13 because that's really long. Let's do n equals 4. So this is not Python I'm coding. I'm just going to walk you through the interpretation here. So if n is 4, what's been returned is return fib 3 plus fib 2. That makes sense, right? n minus 1, n minus 2. Well, that those in turn have to get interpreted. So what actually is being returned is, so fib 3, because 3 is bigger than 1, is going to return fib 2 minus, fib 2 plus fib 1. And then what's fib 2 is going to be fib 1 plus fib 0. Okay, does that make sense? If n is 4, you're returning this, but this gets interpreted as this. Now, we happen to know what some of these are, right? Fib 1 is just going to be 1. Fib 0 is just going to be 1. 0, sorry. Fib 1 is going to be 1. And so all we have to handle is this guy. This is based off the list above, yeah, which is based off of which is based off of this mathematical formula. So then this gets simplified once again. So fib 2 is return fib 1 plus fib 0 so we can simplify that again. One plus 0 plus 1 plus 1 plus 0. And you can just add those up. That's equal to 3. So fib 3 is equal to, or sorry, fib 4 is equal to 3. 1, 1, 1. Okay. Do we need to does that make sense? Do we need to go through that again? The take-home message there is that functions can refer to themselves, and they get, just like a Russian nesting doll, they get interpreted all the way down until they reach their conclusion. That's probably the most important thing to take away from that. And based off of that, you could imagine if you're simulating a bunch of cells in Python, right, in a tissue simulation that you're developed, cell 1 may decide to do something based on the state of its two neighbors. Well, those two neighbors may decide to do something on the state of their two neighbors, and their neighbors may decide to do something on the state of their neighbors. And so what CompuCell does is it kind of evaluates all of that as a whole and figures out a stacking order for how to interpret that, and then lets you move on to the next thing. But I think that's probably what you need to know from there. Modules in a Jupyter Notebook format are a little bit different, but basically, if we were to save this Fibonacci series function, if we were to save this function as fib.pi, then we could, on our computer, then from fib.pi, from fib, we could import asterisk, and we'd be able to do stuff with the Fibonacci. We'd be able to do, we'd be able to call this function that was imported. So that's all you need to know about that. You can import a function from a different file as long as it's saved in the same location. And you do end up importing stuff from well-established programs. So there's something out there called NumPy. Right? So NumPy is number or pi for numerals or whatever. It has a bunch of built-in arithmetic things that you can use. And one of them is mean. So you can take the mean of a list and it calculates it for you because we've imported NumPy and we've given an alias NP. So we're saying we're going to use the mean method from NP. If we wanted to calculate, and that saves us the time of adding all of these up, dividing by the number of things in that list. Similarly, SciPy has stuff. There's a bunch of different stuff that's out there that makes certain standard operations faster. And we borrow some of those sometimes. So whenever you see an import, that's happening. It's importing a package from somewhere else that to speed up something. Okay. Now we get to the interesting part, finally. So everything we've done so far has been one-dimensional objects, right? A list is inherently one-dimensional. Right? A list those are all like in a row or whatever, right? Even if it was a nested list, it's still a bunch of objects in there. And the only way to keep track of those objects is based on the order that they're in. This is very limiting for complex simulations. You could imagine trying to keep track of 100 cells in a list and then keep track of their volumes in a parallel list and keep track of their division rate in a parallel list and keep track of the receptor portfolio in a parallel list. It'd be a big mess. Instead, we can use something called a dictionary. And actually, dictionaries aren't even necessarily what gets used, but this is one step along the way. A dictionary uses labels instead of order to keep track of what's what. And a dictionary, so that's called a key and value. So if we start a blank dictionary like this, my dict equal, and this is just the example that's on the screen there. My dict equals that. That's an empty dictionary. So let's say as I said before, you can have certain structures. So you need quotation marks around all strings. Okay, so these are completely made up, but you could imagine you'd have a cell with volume 22, whatever that means, division rate 4.1, and 88 TGF beta receptors. And then you could imagine you have a second cell. Right? And you can have this repeating structure there. And you can keep track. So then if you want to access, so before when we access things in lists, we would access them based off of their index position. But now we can access I can access it by their key. Okay. And then similarly, okay, let me just for illustrative purposes, let me just generate two more. And we can iterate through these too. So we can put this in a list. So I have an error. I didn't update that. Okay. Yeah. So I can access all the cell volumes, right? I could even increase cell volumes based off of some other variable or so on. So you can see how you can start to kind of keep track of a lot of data through dictionaries. There's another way in module 4 that's more like what Python does. I mean, sorry, more like what CompuCell3D actually uses, but I hope you can start to see how some of these things get put together to keep track of the information you need to keep track of in a given cell. So yeah, so you have keys, values. Keys can be anything, values can be anything, values can be variables. If the key is not found, you get an error, right? So if I try to mydit for cell 3, and I try to access the variable speed, I get the name error. Mydict for, okay, so first I got name error because there's no mydict for cell 3. It's actually a mydict for cell 3 capitalized. And now I'm going to get a key error. Now I get a key error because mydict for cell 3 doesn't have speed. It only has volume division rate and TGF-beta receptors. So that's where I get that key error. We can add key to it simply by doing this. And now it has that speed. And let's take a look at one of the things we've done before. Right? See, we updated the volume right there. This is going to act more like a list in that you can edit it in place, which is helpful when you're trying to keep track of a bunch of different elements. And then you can delete things just like you did for lists with the DEL. So I want to delete the speed variable. See, speed is gone. Okay. Now, when you're iterating through a dictionary, the way to do that, the way to list what all the keys are in a dictionary is dot keys, right? And it presents them there as a list, and you can iterate through that for X in my dict for cell 3 dot keys, and then you can iterate through that with a for loop. You can do it based on order sometimes, but it's not a good idea because dictionaries, so before Python 3, in Python 2 and earlier, dictionaries had no order. They would come out in a random order. The key and value would come out in a random order every time you used it. Now they try to keep it, now they want it to have an order and keep it in the same order every time, but you still can't quite count on it. So you should always use keys. And that's the whole point of a dictionary anyway, right? Is that you have these labels for data. So go ahead and use those labels. So we just did this keys. It returns a tuple. And then you can get values too. Or an interval that acts like a tuple, I should say. Right. And it acts like a tuple in that you can't update it, but there's no guaranteed order, Most of the time it does keep the order that it hadn't been meant, that it was meant to, that it was instantiated in these days, but there's no guarantee. So don't focus on the order. Values can be any type. Values can be, so far we've used values that are numbers. Values don't have to be numbers. Values can be letters or lists. I mean, sorry, it can be strings or it can be lists. So if I want to add cell type, I can set it as epithelial, my favorite. It can also be a list. You can also use a list. Let's say neighbor. Right? I can put cell 1, cell 2, and cell 4 as it. Now notice this is wrong, right? Because there's no variable named cell 1, cell 2, or cell 4. So I've got to keep these as strings right now. But if I were to have them as variables, as their own objects, then I could without the thing that's in there. Keys have to be unique. You can't have multiple volumes or speeds or whatever, but values don't have to be unique. The volume and the speed could both be 9. That's not a problem. So this is the key difference between a list and a dictionary. List has the ordered sequence of elements. You look up elements by their integer index. Indexes always have an established order, and index is always an integer. Dictionary matches by the keys or the labels. You look up one item by another item. No order is guaranteed. Key can be any type. Key are immutable. Values are not immutable. Okay. This is an example. We're not going to do it because I don't have lyrics for us to do it with, but let's just talk through what it is. So we have a function, right? That's DEF, means we're defining a function. This is the function name, lyrics to frequencies, and the input is lyrics. And you start with an empty dictionary. And then for word in lyrics, meaning anything that's in lyrics, if lyrics is a list, it's going to be each item in the list. If lyrics is a string, it's going to be each character in the string. And if the word, if whatever that thing is, whatever you're iterating through, if it's already present in my dictionary, we're going to add 1 to that value. If it's not already present in my dictionary, we're going to add a key we're going to add a key for word, and then we're going to set the value equal to 1. and then we'll return my dictionary, which is going to have a dictionary of everything that's in there. Let's just illustrate that real quick. Okay. It's actually a dictionary counter is what this is. We can do a test arg, right? Curly braces are the defining features of dictionaries, as opposed to the square brackets for lists and the quotation marks for strings. Remember, if and else are always at the same indentation level. And then the return is always at the body level of, or the return is when you want to return. You could have a return statement inside of a conditional if you wanted. Okay, so I've loaded this dictionary. Now we need to create a string. Okay. And then I'm going to call the function or invoke the function with the input argument or input parameter as my string. Then I run it, and it basically counted up all the letters in my string. So there was one capital I, there were 4 T's, 2 S's, 9 spaces, 2 H's, 4 E's, et cetera, et cetera, et cetera. If you'd done it with a list, it would have counted based on the individual items of the list. So what happens? Okay, last thing before we break here. What happens if we do this? If we remove the return statement? So if we remove the return statement, and we run this thing again. Well, okay, hold on. Just to be clear, I ran this thing again and it did the same output, but that's because even though I edited this, I didn't run this again. See, this is 40 and this is 42 and 41 was when this was run before. This hasn't been updated. Now I'm going to run this. Now I've got the edited form of this function. And now I run it and there's no return. Now there's no return there. So there's no output from dictionary counter string 1. There's no output because nothing got returned. So there's nothing to save into memory. Now, if I just do at the end, right, outside the for loop, if I print so I run this, now this could work, right? It just prints the dictionary, but I can't use it for anything. So I have to use my return statement. Return statements are not required. Functions still work without them. But if I want to use that somewhere else, I do need to capture a return statement so that so I can do that. Well, I gotta run this. And then I can access the values permanently now. How many I's were there? There was 1. How many T's were there? There was 4. Okay. That is this lesson. We're getting a little bit better on time as we go. But if there are questions, I know we moved kind of fast there. If there are questions, please speak up now. Otherwise, I'll throw up the poll as we do that. And then we'll take a break before the next session.
I mean, I just thought that I don't know if you addressed, do functions have to have a return?
Yeah, so they do
Python?
not have to, they do not have to have a return statement. But their usefulness becomes less they become less useful without a return statement. Now, if you have a print or something that's going on in there, that's okay, I guess. But we advise using return statements, but they're not required to run. You won't get an error for not having a return statement.
I just have a quick question about for Z and test arg. So for every, so it's pretty much saying like if the Z is the same thing as the original as the other value within the list, it's just being added on to in a key and a value, pretty much, right?
Yeah. Mm-hmm.
And so if it's like a different value, it's just going to be equal to 1.
Yeah, because it's the first time it's in there, it's going to be added to 1. So like if we take this string, like the first thing Z is going to be is I, right? Capital I. And then so it's not already in the dictionary. So it's going to be my dict, capital I is equal to 1.
Mhm.
If there had been and then it's the same thing the first time there's a T, my dict, lowercase t equals 1. The second time there's a T, I'm just for anyone who's listening, the second time there's a T, it's already in my dict. So we're going to update the value.
Oh, okay. Yeah. Got it. Okay, that makes a lot more sense. Thank you.
Okay, great. Anything else from anyone? Does anyone need to see the Fibonacci again or anything like that?
I just had a quick doubt. So you said that, inside your dictionary, you can have lists. Well, I believe you can have dictionary within dictionaries then.
Yes. Yep. It can nest
Yes.
all the way down. Yeah.
Right. So is it a good advice to have several keys for your dictionary or to have dictionaries within dictionary and after some point you can just break into that?
So what we're going to go over in the next lesson is something called an object, and CompuCell uses objects, user-defined objects to handle a lot of this, and that makes it a lot simpler. And then those objects can be kept in a dictionary or a list. But it is common, like if you look at US Census data, that's often what I use in my class at Michigan. When you look at US Census data, it's often a dictionary, and then the high level keys will be like state or something like that. And then inside there will be another dictionary that has keys related to whatever data points there are.
Right. It just
So
makes it more
multi-level
organized.
dictionaries are very common.
I believe
Can you say
that
it
the
again?
issue is to make it more, the reason is to make it more organized, right? That's
Yeah.
okay, cool. Otherwise, for computational stuff, like is one more computationally heavy than the other? Like, will it take more time if I'm just running through, say, a dictionary with several parameters or a dictionary within a dictionary, which is more organized?
I don't know the answer to that. And I don't, it doesn't matter at the scale you use in CompuCell. Maybe at a very big data scale, but in that case, again, you don't tend to use dictionaries as much as you use these custom user-defined objects that we'll talk about in the next session or the next module.
Yeah, I got it. Thanks.
Yeah. The one thing that is computational expensive. So we've done a lot of for loops here. People in Python don't generally do for loops. They do something called a list comprehension. And you can see that on your cheat sheet. We haven't taught it because it is a little bit intimidating of a syntax. but basically it's just a for loop reorganized. And those are list comprehensions are much faster than for loops, even at the scale you'll see in CompuCell.
Okay.
But again, the beauty of CompuCell is a lot of this gets handled by these drop-down menus. So you have to think more about how to organize the system to reflect your interest.